Designing new transport links to get the athletes and spectators into the mountain complex was also a major consideration. Work is underway on brand new road and rail lines from the city of Adler to the Olympic slopes. Both are currently on schedule to be opened in 2013. Trains and cars will run parallel through the mountains over 48 kilometres, and the electric engines that will run here were custom designed for this very project. They'll make the journey in just 27 minutes, hitting speeds of up to 160 kilometres an hour along the way, designed to shuttle 20,000 people an hour from Adler to Krasnaya Polyana. The new route requires 12 separate passenger and service tunnels to be dug through the mountainside at a combined length of 28 kilometres, and the work will have to be completed by 2012 to keep the project as a whole running to schedule. Here they're working with Lovett-designed tunnel boring machines to complete the first of them, the road section of which will be the only one of its kind in Russia. The race against time means that these structures are being effectively designed as they're being built, and the soft sedimentary nature of the soil here has caused for sophisticated adaptation of the existing equipment. Eugene, tell us what about this project makes it special, makes it unique, makes it a challenge in engineering terms?
In engineering terms, what makes this project very, very unique is the time frame that we have to build it. We're using standardized technologies that are very well proven, such as the tunnel boring machines that we're using and the segmental tunneling methods that we're using. Equipment and contractors that have used the same equipment on different jobs, they've just done the modifications to the equipment for the conditions that we have here, such as changing out the cutting heads on the tunnel boring machine so that it is the correct tools for the type of rock that we're encountering here.
The advantage of the TBMs over older drill and blast technology is that they minimise disturbance to the soil around the tunnel itself and produce a smoother inner wall. This reduces the cost of lining the tunnel that they dig. And in rock conditions like they're encountering here, it's possible to simultaneously cut new ground and line the existing tunnel, removing the need for temporary supports. The construction team positioning pre-cast concrete sections directly behind the front shield of the TBM, with the section they're laying supported by the machine's own hydraulic jacks, working like a mechanical earthworm to spew the debris out of the tunnel mouth as it goes. Progress with this kind of tunnelling is, by its very nature, slow and steady. The cutter head dividing its work into 70-centimetre bursts, with the construction workers following on behind to lay in the supporting structures. They've now completed 56 metres, but there's no time to slack because there's another 2 kilometres left to go.